Recently, I was looking for alternatives to Google, but for some reason, there weren't any. So what better solution than to make one for myself? So a search engine consists of three parts: the crawler, the indexer, and the front end. The crawler gets the contents of the websites and finds new ones, the indexer then processes all that data, and the front end allows someone to query it. So let's take a closer look at the crawler. The thing with the internet is that there isn't just a list of which sites exist and which don't, and you can't just randomly try different URLs since most of them won't exist. Now, you could get people to submit websites, which Google partially does, but that's only effective once you're really big. Instead, we have to rely on URLs that we find on the internet, so we'll start with some arbitrary page that we know exists, and then find any URLs on that page, then look at those pages to find any URLs, and so on. So here's a code I'm using to get the contents of the page, and I have some simple text processing here to detect the URLs, and then add them to my database. Now here I just constantly run our function on any website that hasn't been crawled yet, and stop once we hit some number of stored sites. I've set the starting page to the Wikipedia homepage, so let's just give this a quick run and... FBI, open up! What the... Okay, so it turns out you can't just go around willy-nilly requesting the contents of every site you come across. Some sites don't want certain pages to be accessed by robots, and some sites don't want robots accessing their pages at all for some reason. Reddit. There is a standard for this kind of thing, luckily, where sites will include a file called robots.txt under their root URL. It contains rules on which pages you're allowed to or not allowed to look through, for all bots or for specific ones. If you don't follow these rules, the website might be able to detect your web crawler and block it. Even if this doesn't happen, it's a good idea to follow these rules, since they usually disallow crawling on pages that you wouldn't really want to be crawling on anyway. And as a little reward for being nice, sometimes the file will link to a sitemap, which is another file that lists a bunch of important pages on the site for you to crawl. Anyway, I won't bore you with the details on the rules, but I've made the code to parse this file as well as the sitemap file, and now we can crawl responsibly. So now we can try out our web crawler. And it seems to be working pretty good. But right now we aren't storing any useful information about the sites. Now we could just store the entire contents of every page, but thinking ahead, that'll make it hard to search for sites given some query. So instead, let's just store some things that we really want. The first thing we'll store is the incoming and outgoing links of every page, which will be useful a bit later. My current method of finding URLs isn't the greatest, so I'm going to redo it. Instead, I'm finding the links with this regex expression, which matches everything that looks like a URL, as well as anything within an href property of an element, which will always be a valid URL. The second thing we should store is every term on the page, which I'm finding by filtering out non-alphanumeric characters, then separating everything by white space. I have it so that I store every term in my database and link every page the term is in to the term entry, as well as storing every page and linking every term on that page to the page entry, so the links are two ways. This will help speed things up when we go query our database. Alright, so now it's time to try it, and let's just set the limit to a modest 100 right now. Alright, a page can link to the same URL multiple times, so we should filter out duplicates. Oh yeah, and you can put the path only in the href property, and that should link to that path from the end. Apparently you can start with two slashes and make it use the same protocol. And you can use a hashtag for a section. It might be not. Maybe they have random space for the dog type. Oh yeah, just put whatever you want in the href. Okay, so here I learned a very important lesson about the internet. It's a complete anarchy. Sure, there are some conventions that most people agree on, but really anyone can do whatever they want. And there's nothing I can do about it. So I just wrapped everything in a try statement to catch any more edge cases, and now everything works fine. Okay, so now we have everything we need to start getting results. I'll just use this bit of code to get every site that contains every term in our search query, and I'll whip up a simple front end and give it a go. Nice, it seems to be working fine, but it's pretty garbage. It's just giving us websites in the order we crawled them in, and in any half-decent search engine, the results would be ordered so that the most relevant sites go to the top. The most obvious solution here is to save the frequency of each term in the document, in other words, the number of times the term occurs in the page, divided by the total number of terms in the page. For each page, add up the frequencies of each term in our query within that page and order based on the sum. This intuitively makes sense. If we're looking for, say, Obama, a page dedicated to Obama will include the word Obama more than a page about, say, US presidents in general. We'll call this number the term frequency, or TF. This works well, but we can do a bit better. For example, if we search for The Lord of the Rings, our current strategy will give us a site that contains a bunch of the word the. So we have to filter out these common words. A nice way of doing this is to use the number of pages each term is in. We can take this number and divide it from the total number of pages in our database, then take a log of that. This is known as the inverse document frequency, or IDF. If we take the term frequency and multiply it by the inverse document frequency, we get a number known as the TFIDF of a term. We can calculate this for every term in a query, add all those up, and sort by the result. This works well, but it's easy to abuse. Just spam a few specific terms and your site gets bumped to the top of the search rankings. Well, it's a good thing the creators of Google thought of this already. They made an algorithm called PageRank, named after its creator, Larry Page, a very fitting name. Basically, this algorithm determines how reputable a page is based on how much it's linked to by other sites. Start off by giving each page a PageRank value of 0.25. For each page, distribute its PageRank evenly among its outgoing links. Now, just repeat this process a few times until it settles. The pages that are linked to by many reputable sites get a higher PageRank and are therefore more reputable themselves. This algorithm is meant to simulate someone surfing through the sites and randomly clicking on links from site to site. We can improve this slightly, however, by simulating a random chance that the surfer gets bored and hops onto a random site. I'll set the chance to 15%, and we can simulate this behavior by distributing 15% of a page's PageRank among all pages, then distributing the remaining 85% among its outgoing links, just like before. We can run this algorithm after a crawling step and store the PageRank of each page. So now when a user searches something, just like before, we'll get every site that contains every term in the query, but now for each of those sites, we'll calculate the TF-IDF of each term, take the sum of those, multiply it by the site's PageRank, and then sort it based on that product. And testing it out here, it's working pretty good. But right now, all we have is 100 sites. That's basically nothing. For reference, Google has upwards of 400 billion sites in their index, and even just the English Wikipedia alone has over 6 million articles. So I'm going to bump up our limit to 2,000. And running this exposed a pretty big issue in my crawler, which was that it was just slow. Like, really slow. And it only got worse as I switched to a database on the cloud because my own hard drive was getting too full. It was taking upwards of a minute per site, which was simply too slow, so I had to optimize. I won't bore you with the details, but it mostly consisted of finding which parts took the longest, then messing with SQL queries until I got something a bit faster. Eventually, through trial and error, I got the time to crawl, parse, and store everything about a website down to 2 to 3 seconds per site, and I sped up the time to query from over a minute to 5 to 10 seconds. I also changed the starting page to this list of websites on Wikipedia, since starting from the Wikipedia homepage meant I got a bunch of Wikipedia articles and not much else. So I bumped the site limit to 50,000, ran it, waited a couple days, and as the crawler got closer to 50,000, it gave me one final edge case to deal with, an infinite redirect loop. I ended up just fixing this manually, and finally it was done. Now 50,000 is a far cry from the 400 billion links in Google, but it's already taking up 5 gigabytes of storage even with significant storage optimizations that I made. Regardless, you can try it out yourself at the link in the description or the pinned comment, whichever YouTube will let me do. Be warned though, my database provider pauses my instance after a few days of inactivity, so it may not be working for you. Anyway, that's it for this video. If you enjoyed it, press any number of the buttons below this video because YouTube enjoys that. Also, my last video did way better than I thought it would, so thank you everyone for that.